We love
it's
SQL
nice.
Friday.
Oh, yeah. So today I am not in my office. I am in Stockholm for Data Saturday. So I'm on a pre-con with Heini Ilmarinen. So it's a bit back and forth for me, but the way I do SQL Friday is to just keep it as casual as can be. So then I can do it from anywhere at any time. So with that said, Guy, you're so welcome, and I'll just hand over to you now. And for everyone else, if you have questions, just type them. I'll monitor the chat for Guy.
Sure. Thank you very much. Let me share my screen. Can you see my screen?
I see the screen.
Excellent. So hello everyone, my name is Guy. I'm going to talk about how to use parameters in SQL Server and Azure SQL to boost performance. This is a really, really important topic from my experience at least, and I've been working with SQL Server for the past almost 25 years, I think. I saw so many environments and systems and developers and DBAs doing all kinds of stuff. And from my experience, most of the times when you have performance issues, it has to do some way or another with wrong handling with parameters or variables or whatever. So I think it's a very important topic. And some more stuff about myself. I'm a data platform MVP. I'm from Adera Data Solutions. We are based in Israel, provide data solutions and services to customers worldwide. You have here my details. We do a lot of... There's some noise. You can mute yourself, please. Okay, thanks. You can follow my blog. I write quite a lot about the Microsoft Data Platform. We do a lot of community stuff, a lot of activities for the community. Some of them are in Hebrew and specific to the local community in Israel, so maybe less relevant for this audience. Two things that I want you to be aware of is SQL Server Radio. We are doing a podcast, me and Eitan Blumin. We release an episode once a month, and we talk about everything related to SQL, whether it's new features, projects that we've been involved with. Sometimes we interview people, all kinds of people, and anything related to this topic. So I think it's quite interesting. If you like the format of podcasts, so go ahead and subscribe. And another thing is the Madera Toolbox. We have a repository in GitHub. It's an open source, and we upload constantly scripts and solutions that we develop. There is a lot of stuff there. You should go and search for things, all kinds of utility scripts, very useful stuff for working with SQL, completely free. So let me I prepared two links. I'm going to put them in the chat. One of them is for SQL Server Radio, if you want to subscribe. And the other one is for Madera Toolbox, the GitHub repository. So it's in the chat now. Feel free to subscribe. And thanks. Let's move on. Okay, so we're going to talk about parameters. Let's begin with a story. I always love to begin this session with a story. And the story goes like that. I get a phone call from a customer. It's usually 2 a.m. at night or something like that. And the customer says, nothing moves, everything is slow. You got to help us. And I'm saying, okay, relax. Tell me what exactly happens. And they say, we have this stop procedure, for example. It used to run for less than a second. And now it runs for 5 seconds each time. It's not just a one-time issue. At some point in time, this same stop procedure, nobody did anything. It started running for 5 seconds constantly instead of less than a second as it was before. And I say, and it started at 2 a.m. in the morning. And I say, okay, what happened at 2 a.m.? Something happened at 2 a.m., right? And the customer swears nothing happened. It's 2 a.m. We didn't do anything. And I said, okay, maybe there was a restart of the server. No, there wasn't a restart. Maybe you changed the code. Of course not. Maybe you loaded a lot of data. There was some process that loaded a lot of data. The distribution of data changed. No, nothing like that. More questions, more no. Okay, the customer swears nothing happened. It just happened like that. And this is a story. It happens to me once in a while. And of course, the question is why, how can it happen? By the way, let me tell you that in most cases, the customers lie. Something happened, and they won't tell me about it, or they don't know about it. No, really, in most cases, there was something that happened, and we just need to find out what happened and then, of course, fix it. But in this specific case, and it happens once in a while, really nothing happened. The customer is right, it's correct. Something happened within SQL Server automatically, and I want to talk about that. Okay, so this is a story. We're going to talk about what is exactly parameterization or parameters in SQL Server, why I think at least it is so important, and very importantly, when it becomes problematic. Sometimes it's great, sometimes it's going to give us a headache, and when it does, what can we do to solve it, to fix it? Okay, so this is the scope of this session. When I talk about parameters, I talk about this thing here. Okay, so we have the workloads, we have a predicate. It can be an equality operator, inequality operator, between, whatever. The values that we use, like this one or this one or that one. Okay, so this is, generally speaking, I'm calling those parameters. Okay, we're going to see all kinds of examples and use cases how to handle them. For the sake of this session, I'm going to use the customers by country case study, a very simple query. It goes like that. I have the marketing customers table, and I'm going to select from the table where country equals something. We have a country column with a 2 characters country code, and each time I want to receive all the customers from a specific country. That's it. Very, very simple. I'm going to create an index, an unclustered index on the country column, and we'll see what happens with different values that we put here. Okay, so that's the case study. Let's see a demo. Let's start with a demo. Where is my demo? Here it is. So, of course, I'm going to share all the slide decks and the scripts later. You're going to get everything. Here is the query. Okay, a very simple one. I'm going to add the actual execution plan. I'm going to run it. Okay, so we get, in my case, I'm from Israel. We have only 49 customers from Israel because it's a very small country, you know. And if you look at the execution plan, then, as I said before, we have an index, an unclustered index on the country column. We get an index seek and a key lookup because we still need other columns. The index does not cover the query. In this case, only 49 key lookups. That's a great query plan. Everything is great, wonderful. We can move on. Let me close this. Go back here. Let's talk about plan caching. What happens when I run this query behind the scenes? So whenever you run a query in SQL Server needs to check whether there is already a plan for this query in the plan cache. Okay, there is an area in the memory of SQL Server called the plan cache. SQL Server caches execution plan, so it doesn't have to compile a plan for each query every time. It takes a lot of resources, mainly CPU resources. So we have this cache. We want to be able to reuse plans as much as possible, which means that in the first execution, whenever you execute a query for the first time, it's still not in the cache. SQL Server will compile a plan, put it in the plan cache, and from that point on, whenever SQL Server encounters the same query, the same text, it verifies whether there's already a plan in cache, and it can use it. So it goes something like that. Okay, you send a query, SQL Server needs to check whether there is a plan for it in cache. If there is a plan, it still needs to verify that the plan is valid. And what that means, maybe something happened since the last time this plan was used. For example, you changed the schema. If someone added a column to the table or added an index or removed an index, this plan is not valid anymore because something changed. We need to recompile and generate a new plan based on the new situation. Okay, so that's one reason why a plan might become invalid. Of course, statistics change. That's a very common scenario. SQL Server maintains statistics automatically. For each column in every table that you use, there is a statistics, a histogram, and SQL Server tracks the number of changes to that column. And when it reaches some threshold, it automatically updates statistics. Or alternatively, maybe you have your own process that manually or automatically updates statistics. And whenever statistics gets updated, the next time a query that relies on that statistics is executed again, SQL Server needs to recompile because now there is a new histogram. Maybe there is a better plan. So the plan is not valid anymore. And of course, there are other reasons why a plan might become invalid. So SQL Server needs to make sure that the plan that is currently in cache is valid. If it is, it will go to use it right away. Otherwise, whether there is no plan or the plan is invalid, it will need to be compiled again and then executed. Okay, so this is the process. And let me show you a demo about plan caching. So I'm going to create a view called cache plans, and I'm going to select from several DMVs. DM execached plans, which returns all the execution plans in the plan cache, and cross apply to two functions. One of them returns the query plan itself, the XML show plan, and the other one the text of the batch represented by that plan. And I'm also going to join sysdm exequery stats just to get the last execution time so that I can later order by that value and see things chronologically. So I'm going to use this view many times. This is why we create a view. And let's see what happens now. So this is my laptop. Currently, I have all of those execution plans in my plan cache. Okay, so you can see all types, all kinds of queries. Some of them are ad hoc, prepared, procedures. You can see the plan itself. Here's just a very simple example. So this is what we have now on my laptop. If I run this command, which you shouldn't try at home, or maybe at home, but not at production. Okay, this command empties the plan cache completely, and I'm going to use the view again. So now it's empty. I have nothing in my plan cache right now. Let me execute now our case study query, all the customers from Israel, and select from the view again. This time, I'm going to add some filters to get just the query that I'm interested in based on the text, only with customers. So here it is. It's in the plan cache. I can see the text of the query I just executed. I can see the plan as we saw it before. It's currently in the plan cache. I see it was executed once so far. It's an ad hoc query, meaning there are no parameters in this query. Everything is ad hoc. Okay, so if we look here, this is an ad hoc query because we have a literal, a constant value, no parameters. It's called ad hoc. It's the size and when it was last executed. What happens if I run the same query again? We look again in the plan cache. So now we get execution count 2. And this is great. SQL Server didn't have to compile a plan again. It verified there is a plan for this query in cache. It's valid. Let's reuse it right away. Okay, that's great. And generally speaking, when you look at something like this view in your production environment, you want to see high numbers in this column. Okay, so because that's the whole purpose of the plan cache. Otherwise, it's a waste of resources. You want to be able to use the plan cache in a good way, meaning reusing queries and not just seeing here many lines with 1 or 2 as the execution count. All right, let's do this again. I'm going to run this query for the third time, the same query. And if I look at the plan cache now, I see a second row. What happened? Okay, we're supposed to reuse the plan again and again and again. I cheated. I did. I added a space here. Okay, and what I wanted to demonstrate is that the way SQL Server searches for a plan for this query text in the cache is by calculating a hash value over the query text, the entire query text. Well, not with the Go, but this one. Okay, and it's very stupid in the sense that it doesn't parse the text. It just takes the entire text, including spaces, white spaces, and so on, calculates a hash value and searches for that hash value in the plan cache. Now, since I added a space, it's a different hash value. As far as SQL Server is concerned, there is no plan for this query. It needs to compile it again. Of course, in reality, when we develop applications and write queries, we don't do it once with a space, once without a space. Okay, it doesn't really make sense. What we do is we use different values. This makes sense. Sometimes we want to look for Israeli customers, sometimes French customers, German customers, US customers, and so on. So this value is going to change. This is the same problem. Okay, it's a different text. It's a different hash value. So if I run this, look at the plan cache, we have another line, French this time, another head hook, another 16 kilobytes, another compilation, and so on and so on. And this might become a problem, sometimes a big problem. In our case, let's say we have, I don't know, 200 different unique countries. So potentially we have 200 compilations for the same query and 200 plans, maybe the same exact plan, but 200 instances of this plan in the plan cache, taking up memory, and so on and so on. This is a small problem. It's only 200. Think about another example where you have a query, let's say, based on transaction ID or something like that, where transaction ID equals something, and you have millions or billions of different transaction IDs, and you put there a number, a literal number. Each time a different number, you have billions of compilations, and so on and so on. You get the idea. This might become a real problem. So this is what happens when we don't use parameters. And I hope that by now I convinced you that it's a good practice to use parameters. Now we will see what happens when we use parameters. So let's move on. Okay, so this is how plain caching works. And the next topic is based on a very famous song by Paul Simon. Instead of 50 ways to leave your lover, I say there are 7 ways to execute your query. I have the song here, but I don't think that, no, I'm not connected with the audio. So either you know this song or go later, listen to the song. I love this song. And I want to demonstrate how we can run the same query in 7 different ways and what happens in each way. 7 ways to execute your query. Okay, so I'm going to empty the plain cache to start from scratch. And let's set the execution plan. So the first way is non-parameterized SQL query. Basically, it's what we already seen before. Okay, we're using the constant here. First with the Israeli customers, we look at the plain cache, just like we saw it before. Okay, we had a compilation now for the first time because the plain cache was empty. And I'm going to run the same query with French customers. And of course, we get another compilation. We have 2 lines, 2 different plans, which is the same plan essentially, but 2 different instances of this plan in the plain cache. And this is way number 1, okay, the first way out of 7. Way number 2 is non-parameterized dynamic SQL query. What I do here, I declare a local variable called country, in this case IL. I declare the query text, and I put in the query text my query, and then I concatenate the value of country right into the text. So the result of this is just like this one. Okay, it's going to be the same text eventually, and then I'm going to dynamically execute whatever is inside query text. Okay, so let's do this. And then we have yet another compilation, another plan. It's still ad hoc. Okay, the important thing to understand here, there are no parameters involved in this query because I'm adding the value into the text, injecting the value into the text itself. So it says country equals IL, a constant value. So it's the same. If we look here, this query is just the same as this query, and it's the same plan. It's an ad hoc plan. And actually, you might ask, so why SQL Server didn't reuse this one? It's the same text. And of course, the answer is, you can see from here, there are different white spaces. That's the only reason. If I had built the dynamic text to be with the exact same white spaces as this one, it would have reused the same plan. Okay, it's the same thing. Because the dynamic text itself runs in a separate batch, just like the batch that I used previously. And of course, if we changed only the value of the local variable, the country, and put it here, and we get the same behavior as before. We're now going to have another compilation, which is this one, FR. All right, this was number 2. Number 3, now for the first time, let me present to you parameters. Let's use a parameterized dynamic SQL query. So it's still dynamic. I'm still using query text to build dynamically the statement, but this time I introduce a parameter into the dynamic text. I called it P country to differentiate between this one and this local variable called country. Okay, and I'm also declaring now the parameters. So the parameter is P country, it's ncar2. And then instead of using, execute, as before, I'm going to use sys sp execute SQL. The statement is the query text, this one. The parameters involved in the statement is what I declared here. And for each parameter declared here, I can now pass a value for this specific execution. So I'm going to pass into the P country parameter, I'm going to pass the value of the country local variable. So it's essentially like a stored procedure, but an ad hoc stored procedure. Okay, I don't really create an object like a stored procedure, but I'm passing parameters into the dynamic batch, and I'm running it with this parameter inside. Notice that the text never changes. It's always the same static text. There are no values inside this text. The values are passed as parameters. It's a different type of execution, which means that if I run this now and look at the plain cache again, we have another line, but now it looks different. First of all, it's a prepared plan. Prepared is a terrible name. It means a parameterized query. Okay, prepared meaning we have parameters in this query. And if you look at the text, the query text, the way SQL Server presents the text, it first puts the parameters in parentheses before the text itself, and then the text of the query itself, like this. This is the way you see it in the plan cache, and of course the plan itself, and so on and so on. Okay, so it's a different type of plan. And of course, the nice thing about it is now I'm only going to change the country name here, which is going to, it doesn't change the text. It's going to be passed here as a parameter value for the second execution. But now, since it's a prepared statement, SQL Server is now able for the first time to reuse the plan because it realizes it's the same query with a parameter, only the value of the parameter is different now. Okay, and in this case, it can reuse the plan again and again, each time for a different parameter value, which is great. All right. Number 4. This was number 3. Number 4 is the non-parameterized client-side query. So I want to show you how it behaves from the client application side. So I have here, so somewhere, here it is, a very simple .NET application that I developed. I'm going to put here the country name, and I have two options. I can run it as a non-parameterized query or as a parameterized query. Let me show you very briefly the code. This one, okay. So here is the C# code. Very simple. I'm going to open a connection, and then if I click the non-parameterized version, what it does, it puts in the command text, the select, and then I concatenate here, country equals, I put the value of the text box, just like I did with the non-parameterized dynamic SQL, the number 2 before. Okay, the same way, just coming from ADO.NET. And if I choose the second radio button, the parameterized query, then I'm going to use a very similar version to what I did with the parameterized dynamic query. I'm going to use p country ID, and then I'm going to declare this parameter as an ncar with size 2. I'm going to put into the value of the text box and declare it as an input parameter. Okay, so this is how it looks like from a C# code, more or less the same idea. And now, if we execute the non-parameterized, so it was executed. Let me show you from the server side what happened. So now we have another ad hoc compilation. And again, this one is just like the same exact query as this one or this one. The only difference is white spaces. Okay, and this is why it was compiled again. And if we do it with French customers, then of course we get another compilation. And if we do Israeli customers with the parameterized query, basically what happens behind the scene when I run this code, ADO.NET sends the SP execute SQL statement just like we did before. Okay, so it's the exact same way of execution. It becomes a prepared statement with the parameter, which means we have this line, which is just like this one. It's a prepared, okay, but it's different because it's again different white spaces. Also, we see that it consumes more space because there are some differences in the way that ADO.NET sends the query. So there are some differences, but except for this size, it's basically the same plan, the same process. And of course, the last thing is to change this and to verify that we reuse the plan again here. Okay, let me close this. Let me go, oops. Here, so this was number 4 non-parameterized and number 5 parameterized from client-side query. I did them both in the same way. Number 6 is classic, stop procedure. Okay, so I have a stop procedure with a parameter, which is a real parameter, country, and I'm going to use the parameter here inside the query. Okay, so this is classic. Let me create a stop procedure. The important thing to know here is that when I create a procedure, nothing happens. Of course, SQL Server creates the object and registers the metadata, the code of the procedure, but it doesn't execute or generate any plan for that procedure during creation. Only in the first execution here, when I pass a specific value, SQL Server will create a plan for this procedure for the first time and put it in the plan cache. And in this case, if we look at the plan cache, you have a third type of plan called proc for procedures. Okay, again, it's a parameterized, just like prepared, but it's a different type of plan if you look at the plan cache. If we run the same procedure with a different value for the parameter, in this case fr, then oops, execute. And of course, we get a reuse of the stop procedure. Okay, that's part of the point of using stop procedures. And number 7, the last one, I call it looks like parameterized T-SQL query. Okay, and this might be confusing and misleading. I'm going to declare a local variable called country, put a value, in this case IL, and I'm going to use it here. If we look only at this statement, it looks exactly the same as the statement within the stop procedure. It's exactly the same. But we don't know if this is, if we don't look above, we don't know if this is actually a parameter like in this case, or a local variable like in this case. It looks the same because of the @ sign in the beginning, and it's really, really misleading because parameters and local variables are completely different things. They behave in a completely different way, and that's very important to understand. Let me show you what happens when I run this code. First of all, if you look at the plan, until now, all the execution plans we got were great plans with an index seek and key lookup, as I showed you in the beginning. Now, for the first time, I get a wrong plan, a very poor plan for this query. I get a clustered index scan. SQL Server now scans the entire table just to get me the 49 rows for Israeli customers. Doesn't make sense. And the reason is, if we look here, look at the actual number of rows, which is 49. The estimated number of rows is this number here. I didn't show you, but until now, the estimated number of rows was correct. It was 49. It was perfect in all executions until now. Now, for the first time, we get a wrong estimation. And because the optimizer thought, oh, I'm going to need to return more than 5,000 rows, I better do a clustered index scan rather than do 5,000 key lookups. Okay. If there were really more than 5,000 rows, the optimizer was right. It's a good decision, but it was wrong. And we need to understand why. I'll get to that later. But another problem with this code, if we look at the plan cache, then it looks like, again, let me remind you, we did this. It looks like a parameter, but it's not. Here is the text. It's an ad hoc query. And actually, the entire batch gets compiled, including the declare, including the value of IL here, which is a constant value. So this means if we change only this to FR, the entire batch now gets compiled. Since it's a different text, we get a different hash value, we get another compilation, and it's still an ad hoc query. So if I look at the query plan again, we have another line with only this difference. It's still ad hoc. So we don't get reuse of the plan when we use a local variable, but also we get the wrong plan. We still need to understand why. Let me close this and go back to the slide deck to explain why. So in order to understand why, we need to talk about a very important topic called parameter sniffing. So as I said before, the query plan is generated in the first execution of the stop procedure or the query, whatever. And in that first execution, if you have parameters, if you don't have parameters, if it's an ad hoc query, there's nothing to talk about. There's no parameter sniffing because there are no parameters at all. But if you use parameters, there is a process called parameter sniffing. In that first execution, the optimizer sniffs the values of the parameters. It knows the values in that first execution, and it uses those parameter values and based on statistics to estimate the number of rows, and based on that, what would be the best plan, whether to use an index seek or an index scan, for example. Okay, and this is great because otherwise the optimizer needs to guess somehow and come up with a plan that is good for all cases or the average of the cases. But no, in this case, it uses the parameter values in the first execution, which is great. This is called parameter sniffing. There is no such thing as local variable sniffing. It just doesn't exist. It looks the same. It has the @ sign in the beginning, but it's something else. For local variables, SQL Server does not sniff it. It can't use the values. So whenever you use a batch with a local variable, a query with a local variable, SQL Server treats it as an ad hoc query, and it doesn't have a clue during compile time about the content of the local variable. It is considered an unknown value, and then SQL Server needs to use all kinds of rules, static rules, for how to deal with unknown values. I will show you that in the next demo. Okay, so that's the reason why we get a different plan, and also why it's considered an ad hoc query. Now, the big question here is whether parameter sniffing is a good thing or a bad thing. It might sound like a good thing, but it's a good thing only as long as the distribution of values within the relevant column is more or less uniform. It's the same. So if you get, and also the distribution of queries, by the way, the distribution of how you use parameter values. Okay, this is also important. In this case, the fact that SQL Server can use the value of the first parameter and generate a plan is great, because this plan would probably be the best plan for most cases, at least, because we use the same or similar parameter values that would generate the same plan. Okay, but sometimes you have a column with a different distribution, and for some values in that column, or for some parameter values, you want plan A. For other values, you want plan B. And the problem here is that SQL Server generates the plan based only on the first execution. And now we get stuck with that plan in the cache, and all consequent users and executions will use the same plan. And it will be the wrong plan for some, or maybe for most of executions. And this might be a real problem. If you think about it, if you know how to play blackjack, then when you play blackjack, you go to the table, and the dealer opens the first card. You can see the first card of the dealer, and then you get your 2 cards, and you need to come up with a strategy, with a plan, okay? How you're going to play this game based on the first card of the dealer. And for each game, it's a different card for the dealer. You're going to come up with a different plan, maybe. It makes sense. The way parameter sniffing works is that you can only come up with a plan in the first round, in the first game, based on the first card of the dealer in that first game. And now you get stuck with the same strategy. You must follow the same plan for all the next round. So if the dealer has the ace card in the first game, you come up with a plan, what you're going to do in this game. But now you have to do the same things, the same actions every game, regardless of the card of the dealer. It doesn't make sense. It's crazy, right? This is how SQL Server works. SQL Server is crazy, yes. I have to give credit to this example to Brent Other. I did this session once with a different example, and Brent Other told me, hey, it's like blackjack. I said, yeah, that's a better example. So thanks, Brent. You have to understand that this is how SQL Server works by default. Of course, there are pros and cons to everything. And let's see how it works in practice. Let's see a demo and what we can do to deal with this problem. So, 6IO, actual plan, empty the plan cache, and we are ready to go. First of all, I want to show you the statistics on the country column, the distribution of values. If we look at the histogram here, then as you can see, I created a very simple demo so that I can easily show you what I want to show you. So we have 16 different values of countries, and for some countries, small countries like Israel, as you can see here, we have around 60 or 70 customers. For some countries like China, like UK and US, we have 30,000 or 40,000 rows. So it's a very unusual distribution. Okay. For some values like IL, the best plan would be index seek and key lookup. For some values like US, the best plan would probably be a clustered index scan. Otherwise, we will have to do 40,000 key lookups. Not very good. So this is how it looks like. By the way, if you look at this number, the old density, this is the average density. The average, if you multiply this value by the number of rows in the table, you might recognize the value that I showed you before, the estimated number of rows when we use the local variable. It was more than 5,000. Remember, it was this value. Okay, 5555 point something. And what this means, we had, let me go back to the query. We use this query, this one. Since this is an unknown value during compile time, SQL Server now needs to estimate somehow how many rows are going to be returned for country equals unknown. Of course, it can't use the histogram, but it can use this all density value, the total average. So it says on average, for whatever country, on average, it's going to return this number of rows, 5555. Okay, and this is where the estimated number of rows come from. Of course, in our example, it's not this and not that. Okay, we either have very small countries or very big countries, and we don't have this value in the middle, so it's a very wrong estimation. In reality, we have all kinds of distributions and all kinds of wrong estimations. Okay, but this is where it comes from. Let's move on. Close this one. Okay, so since I emptied the plan cache again, we now have an empty cache. We start from scratch. I'm going to execute the stop procedure for the first time with the value IL. And we get, of course, an index seek and key lookup. As you can see, we have the estimated number of rows is 49. The actual number of rows is 49. That's great. Okay, SQL Server using parameter sniffing could estimate the number of rows based on statistics. Excellent. What happens if another user now executes the same stop procedure, which already has the plan in the cache with a different value, this time US? So now we get 40,000 rows, but it's the same plan. And in the plan, as you can see, the optimizer estimates 49, while the actual number of rows is 40,000. And this is, of course, because it had to reuse the plan from cache. There is already a plan from cache. Let's reuse it. This is how plan caching works. But in this case, we got it wrong. This is a very, very poor plan for this scenario. If we look at the logical reads, so many pages we need to read to return this data. It doesn't make sense. Okay, this is a poor plan. And by the way, some people get it wrong. It's not that the optimizer tried to estimate and came up with the number 49 and it was wrong. It didn't even try to estimate. It simply reused the plan from cache, where it estimates in the first execution when it was correct then. Okay. We can also look at the select operator properties. We have a parameter list here. And we can see all parameters involved in the query, in our case, the country parameter. We can see the compile value and the runtime value. Okay, so this might help you understand what happened. During the first execution, when the query was compiled and the plan was generated, and based on parameter sniffing, SQL Server used the value IL, and this is why we have the estimate number of rows 49. And now in this specific execution, this is the runtime value. We are now using US. This can explain the gap. Oh, this is the problem. And sometimes this is a big problem. It's quite a common problem. Of course, if you have a workload with many different queries, many different tables, for many of them, you will not have this problem. But for some of them, and in most cases, from my experience at least, this problem exists out there. Either you're aware of it or not, okay? And sometimes it's a big problem. This means that for some executions, or maybe for most of the executions of this stop procedure, you get the wrong plan and poor performance. So how do we solve this problem? Several options. Solution number one is very simple. We can use this system stop procedure, SP recompile, and pass the name of our stop procedure as a parameter. And what it does, it simply marks the plan for this procedure, for our procedure in the cache, as invalid. Remember, SQL Server needs to verify whether the plan in cache is valid or not. This is one way to manually, proactively say, I want you to mark this plan as invalid. This means that the next time someone tries to execute this same stop procedure, SQL Server will check. It will see, oh yeah, there is a plan for this stop procedure. Oh, but it's invalid. I need to recompile it again. So it triggers a recompile in the next execution. And during this next execution, we will have parameter sniffing again. This time, the new plan will be generated based on the new values in the next execution. What it means, it doesn't really solve the problem. It just gives us another shot. Maybe in the next execution, things will be better. Maybe in the next execution, another user will use different parameter values that will fix our problem and go back to a better plan that we had before or something like that. Okay, so it doesn't really fix the problem. It's not a really good solution, but it's a very good solution that you need to have in your toolbox, because what might happen, what happens in many cases, is that you get stuck with a very poor plan for most parameter values, for most executions. Okay, it might happen. And now you have this plan in the cache, and most users are not happy. And people are shouting and screaming, they're not happy, and there is a lot of stress around you. And they say that you must fix it. And the first thing you should do is run this, because in such situations, you have nothing to lose. Okay, this might produce a better plan in the next execution. It might not. You might get the same plan again. It will be recompiled, but generate the same plan. But there is a good chance well, I don't know, there is a chance, okay, that you will get a better plan in the next execution. You have nothing to lose. In many cases, it will generate the best plan. And then, first of all, remove the stress, okay? Let people calm down. Now you can sit down and investigate, understand what happened, and fix it in the long term, okay? So it's important to be aware of this solution. Let me demonstrate. Now, let's assume that the next execution is with the value US. So now we get a recompile. Now we get a plan that is the best plan for US customers, okay, with very good and accurate estimations again. But of course, now we have the opposite problem. If the next user comes with a value IL, now they will have to reuse the same plan, and we still get the problem. The estimation is 40,000, the actual value is 49. So we have the same problem in the opposite direction. So it doesn't really solve the problem. Solution number 2, we can use add with recompile. If you add with recompile here to the header of the stop procedure, then what happens is you basically instruct SQL Server to recompile the procedure each and every time. Every execution, it will generate a new plan and throw it away. It won't even put the plan in cache because there's no point. Okay, why consume memory in the cache? I'm going to have to compile it every time. So if I execute the stop procedure now with IL, we get index seek and key lookup. Another user comes along, execute the same stop procedure with US. They get a scan and so on and so on. For each and every execution, we will get the best plan for this specific value thanks to parameter sniffing. This is great. It's the best solution, only you pay for many, many compilations. While in some cases you can afford it, okay? If this stop procedure is used for, let's say, a weekly report, who cares? Each time it runs once a week, spend some more CPU cycles to generate the best plan for this specific execution and then run it. That's great. Even if you run this stop procedure once every few seconds, in most cases, it's okay, because the overhead of compiling is usually a few tens of milliseconds, something like that. Okay, it's no big deal. Of course, it depends on your environment, the CPU stress, and so on. You need to test. But on the other hand, if this is an OLTP system and this stop procedure is executed concurrently many, many times per second, this is very, very dangerous. If you're going to add this with recompile, you might bring your service to its knees. Okay, it's going to be 100 CPU all the time. It will be busy just compiling your stop procedure all the time. It's risky. Okay, so be careful, test, make sure that you add this with recompile only where appropriate. Okay, but if you can afford it, great solution. Very simple, very affordable. You get the best plan each time. But there is a better solution than with recompile. You can use option recompile. There are two differences between with recompile and option recompile. With recompile, you put it here at the stop procedure level, in the header of the stop procedure. Now, we only have a single statement in the stop procedure, but imagine, of course, I'm sure that you have stop procedures with 20 or maybe 100 different statements, a whole batch, a whole process. So if you have many, many statements in the stop procedure, this will recompile the entire stop procedure, all of those statements every time. That's a lot of overhead. And maybe you only have a problem with the fifth statement. You only need to recompile the fifth statement each time. Okay, so instead of doing this, you can add option recompile. This is part of the statement. It's part of the select statement. You can add option recompile only to the statement where you need it to be compiled. So you have a plan for the entire stop procedure in the cache. And during runtime, in each execution, when SQL Server gets to the fifth statement, only then it recompiles only that statement. Okay, so that would be better. You have more flexibility there. And another difference, which is very, very important, this happens at compile time, and option recompile happens at runtime. It might sound like, what's the big deal? It's a big deal. Because during compile time, before even starting to execute the stop procedure, SQL Server now needs to generate the plan for the entire stop procedure, okay, which is what happens using with recompile. And during compile time, there are many things that the optimizer doesn't know and can't use. Things like we talked about local variable earlier. So I said that local variable is an unknown value during compile time. But if you use option recompile, and if I had here a local variable, that's not a problem, because during runtime, at the time that SQL Server gets to this statement, it already knows the value of the local variable. Just as an example, there are many things that the optimizer knows during runtime, which improves plan generation and can optimize performance. So option recompile is really, it's like magic words for me. You just add option recompile and it's like magic, okay? But the same thing I said before, the same disclaimer, be careful, okay? If you add option recompile to a query that runs many, many times per second, this is very, very dangerous. But if you are sure that this query runs just once in a while, this can be a great, great improvement by just adding these two words. That's it. Okay, so let me demonstrate. Of course, in our case, we won't notice any difference. It's still going to be index seek lookup, and in the next execution, it's going to be a clustered index scan. Okay, so great. But let's say you can't afford it. Okay, this top procedure is executed many, many times. You don't want to use either with recompile or option recompile. Another solution is to use optimize for, option optimize for. Again, it's part of the query. It's a query option, the select statement. And what you say here is I instruct SQL Server instead of parameter sniffing, instead of sniffing the actual value used here during compilation, I instruct SQL Server to always use this value. Okay, ignore the value here passed by the user. When you compile the query plan, always use the value US, for example. Okay, of course, the results during execution time will be based on the actual values passed here, but the plan will always be based on US. And this is a good solution when I am very familiar with the data distribution. And I know that, again, not just data distribution, the workload distribution. If I know that in 99% of the cases, users use the value US, for example, then this might be a good solution. Because I at least want to be able to get the plan for US for those 99% of the users. And I'm willing to pay for poor performance for those 1% and not the other way around. Okay, because if I don't instruct SQL Server how to use the parameter value, then what might happen, and this is the big deal here, is that during the first execution, if some user uses a non-standard value, the 1%, then we're going to get a plan based on that value. And then everyone, all the rest, 99%, will have to reuse the plan that is inappropriate for them. Okay. So again, this might be a good solution, but it's very risky. I have to be familiar with the data distribution. I have to know how many times this value is used and so on and so on. And in most cases, we don't know, or maybe we think we know, but it might change in the future. Okay, but just to demonstrate, even now when I use in the first execution, I use the value IL, we already get a plan based on US with the estimated number of rows 40,000. Okay, of course the actual result is 49 rows. We get the Israeli customers, but the plan is already based on US because this is why I instructed SQL Server to do. Of course, now if we use US, we will get the correct plan. The last solution, solution number 5, is for complicated scenarios. And in this case, what I can do, and I'm showing you just one example of it. What I'm going to do, I'm going to create a table called common countries. The schema of the table has the exact same schema as the statistics, the histogram that SQL Server uses. Because what I want to do, I want to populate my table with the histogram of the country column using this command. So now, if I select from my table, I have the entire histogram as I showed you before. And now I can use some kind of logic, and there's a lot of trial and error here, to distinguish between the common countries with many customers and the uncommon countries. Okay, and of course this is again a very, very simplified example. But what I'm going to do here, I'm going to count the number of rows in the table, and I'm going to delete from my table called common countries all the countries where the number of customers is less than 1% from the entire table. Okay, so I'm going to basically delete all the small countries and leave only the big countries in the table. So we are left with China, UK, and US. Okay. So again, this is a very, very simple example, I know, but I can tell you from experience that I did this kind of solution for customers several times. It worked well, but it requires a lot of trial and error and testing and maintenance. So it's not that simple, but when it works really great. Let me show you what happens now. I'm going to create a new stop procedure called customer by country _ common with the same parameter, the same query, and another stop procedure the same stop procedure only with the name uncommon. And now I'm going to change the original stop procedure to make it transparent to the application. So the application continues to run this stop procedure, but now what it does, it checks whether the value of the parameter exists in my common countries table, which is a very small table. If it does, it's going to execute the common stop procedure. Otherwise, it's going to execute the uncommon stop procedure. And the nice thing is that the first time each one of these stop procedure is executed, it also has parameter sniffing. And since I always make sure that I pass it the correct type of value from the correct group, then the common stop procedure will generate a plan for the common countries and will always get common country values. And the same goes for the uncommon. Okay, so the external stop procedure now becomes like a router. Okay, which one to run each time. Let me show you. Now, first I'm going to use IL. The first plan here is the if exists to check if the value exists in my table. And the second one is the actual plan I got with the index seek and key lookup. And in the second execution with US, we get a cluster in the scan. So the good thing here, we don't have to compile every time. We only have 2 compilations, only twice, and that's it. And now we can reuse each one in the correct way. The bad news is that we pay for this overhead. And sometimes the cost of checking the if exists might be more than compiling each time. Okay, so we didn't do anything in this case because we still need to check each time, and maybe it requires more CPU resources. It really depends. Okay, it depends on the workload, on the query, on the table, and so on and so on. Again, in some cases, I tried it and it worked really well. Some others it didn't, but it's worth trying. So those are the solutions for the problem. Let me go back here and just summarize. So we can use SP recompile just to make sure that we try again and maybe we get a better plan the next time. Not as a long-term solution. We can use read recompile, but actually don't use recompile because I think that it's always better to use option recompile at the statement level, both because it's at the statement level and also because it happens at runtime. You might want to use option optimize for, but it's really, really dangerous. Be careful with that because you need to really be aware of the distribution of workload queries and data. And I show you the last solution of using multiple stop procedure, which might be an option in some cases. The next topic I want to talk about is what happens when you change parameter values. And I see many developers do that. Let me show you a demo, an example. So I'm going to use a different query now, different stop procedure. And again, let's do all this setup. And my stop procedure now is called customers by last purchase date. It has a parameter date. It has a default value of null. And what I do here, if the date is null, then make it 1 month ago. And then I have a query, give me all the customers where the last purchase date is greater or equal to date. So what happens is there is let's say a search form in the application, and the default behavior that the users want is give me the last month. So in this case, they don't need to do anything on the form. They just click submit right away, or maybe even it's executed by default, and they get the last month because the application passes the value null. But if the user, the application user wants something else, they can always use a date picker and choose a different date, and then they pass a different value, and we bypass this if statement. We're okay. Okay, so again, I see developers do this all the time. It's quite common. And it might look like a good solution. Let's create an unclustered index on the last purchase date, in this case, to make it interesting. And now, first, okay, it's an old demo. Let's make it 21. Let's run the stop procedure for the first time with this value. We get 63,000 rows. Okay, we get a good estimation. Everything is great. We get a clustered index scan in this case because it's a lot of rows. And now I'm going to execute the stop procedure again. This time without passing a parameter values. Okay, the with recompile instructs SQL Server to recompile it again because I don't want in this case to reuse the plan from cache. I want to show you what happens if we run this stop procedure for the first time with without a parameter value, and it will use the default value of null, okay, which is supposed to be the common case. So let's say now it's the first execution, and as you can see, SQL Server estimates 1 row, only 1 row, to come back from this, but actually we have 8,000, more than 8,000 rows. So this is very wrong. For 8,000 rows, probably it's not worth doing so many key lookups. Okay, we got a poor plan. And why it happened? The reason it happens is because of parameter sniffing. Parameter sniffing uses the value at compile time, the value passed by the user. In our case, it's null, because the user didn't pass any value. It uses the default value of null. So during compile time, now SQL Server looks at the entire stop procedure and says, hey, I have a select statement here. I need to generate a plan for it. I use a parameter. During compile time, as far as I know, the parameter value is null. So now SQL Server needs to estimate the number of rows. How many rows are in the table where last purchase date are equal or greater than null? And of course, there are 0. Okay, in this case, the estimate value is always 1. It will never be 0. So it says 1. And of course, at runtime, we run this code. We change the parameter value to last month, and then we execute it. It's something else. Okay, so we fool SQL Server to think it's null, but actually we're going to use later a different value. That's a problem. And we have several ways to solve it, or at least try to solve this problem. And one of them is to put the logic of this if statement inside the query itself with the isNull function. Okay, so in this case, during compile time, SQL Server should look at this, and assuming it's a null, based on the isNull function, SQL Server now should be able to know that it needs this, and it will use the correct value. If we run it, then we now get a different plan, but again, we have a very poor estimation in this case. Now SQL Server estimates 30,000 rows compared to the 8,000. And this is a very round number, okay? Where it comes from. The problem here is the isNull function. You should know that the isNull function itself is an unknown value during compile time. During compilation, SQL Server doesn't know how to evaluate this expression. So this entire expression is unknown during compile time. And again, SQL Server has rules for how to deal with unknown values. In this case, when you have an inequality operator with an unknown value, SQL Server always estimates 30% of the table. It says this predicate will return 30% of the table. The table has 100,000 rows, so it says it will return 30,000 rows. And of course, there is nothing to do with the actual value. It's just a wild guess, okay? So this is not good. What we can do, we can use a local variable. Instead of changing the parameter value, I can declare a local variable and pass to the local variable the value that I need, whether it's the same value of the parameter or if it's null, 1 month before. And then I'm going to use the local variable in the query. If I run this, I execute it, same problem, 30,000. Because, as we said before, a local variable is also an unknown value during compile time. And basically, when I do this, I completely disregard the parameter. There is no parameter sniffing anymore involved here, because we don't use the parameter in the query at all. Okay, so it's the same problem. Solution number 3 is to add option recompile. And again, this will instruct SQL Server to recompile the statement again and again every execution, but it's going to happen at runtime. And in this case, whether I change the parameter values or I use a local variable, or if I use an isNull, all of those problems will disappear using option recompile, thanks to the fact that it happens at runtime. So in our case, if we change the parameter value during runtime, we already know the new value of this parameter, and now we get a good plan with a perfect estimation. So again, option recompile solves the problem. It's like magic, as I said before, but you should be careful. And the last solution, I think it's the last one. Yeah. So again, similar to the solution from the previous demo, I can use a separate stop procedure called an inner stop procedure, for example, with the same parameter and query. Let's run it. Then I change the original stop procedure with the default value of null with the same if. But after the if, instead of just running the query, I'm executing the inner stop procedure and passing it the value of the parameter after the change. And this inner stop procedure also has parameter sniffing, but this time with the correct value. So this is another way to solve the problem without having to recompile every time. So as you can see now, we get the correct estimation. Okay, so those are some options to solve this problem. And I know that I'm out of time, right? So let me, I'm going to skip this one, which is, I think, less important. Let me skip to the summary. Here we go. So I would like to summarize what we learned today. First of all, I hope that we learned that parameterization is a very important topic in SQL Server and in Azure SQL as well. And again, like I said before, it will impact performance in a very meaningful way. If you don't handle parameters properly, you will suffer. Okay, this will improve performance, and I see many developers do the same mistakes of using local variables, changing parameter values. They have non-uniform distribution and they don't handle it, and so on and so on. Some tips you should take away. It shouldn't happen, all those clicks. Sorry about that. So usually, in most cases, data distribution is more or less uniform even, and you don't have a problem with parameter sniffing. Parameter sniffing is great, but sometimes it's not, and then you need to deal with it. And I showed you some options how to deal with non-uniform distributions. Okay, this was, wow, there's so much mess here, the slides. So this was tip number 2. Tip number 3, use option recompile when appropriate, okay? And option recompile will solve all those problems of changing parameter values, different distributions, local variables. It will solve everything, really. But make sure that you only run the relevant query once in a while, not too much, or don't use option recompile everywhere, and then everything will have to be recompiled. Okay, so use it with caution. Tip number 4 is don't change your parameter values inside store procedures, or don't use local variables. Use one of the options I showed you, either option recompile or use an inner store procedure, which will also have parameter sniffing. And this one is the one I skipped. It's about forced parameterization. Don't use it. That's the bottom line, more or less. Okay, so let me just get back to the story. The customer called me at 2 a.m. in the morning. They swear they didn't do anything. The store procedure that was executed for less than a second each time now started to run for more than 5 seconds each time. Okay, it happens once in a while. And I hope that by now you understand that the reason is statistics update. SQL Server automatically updates statistics when it reaches a threshold. Unfortunately, it happened in this case at 2 a.m. at night. And during the next execution, it's just a matter of luck. Bad luck in this case. During the next execution, since the plan is now invalid, then Glantser use a very non-standard value for the parameter of that store procedure, which generated a different plan, a very poor plan for most executions. And now the customer was stuck with that plan, which runs 5 seconds each time. Okay. And again, this is the default, the way, SQL Server behaves by default. Okay. It's by design. It's not a bug. It's by design. You need to understand how it behaves and how to handle it. Thank you.
Thank you, Guy.
Do you have time for questions?
I do.
Have questions?
Let's see if we have any. I see something. There was one question about the scripts for the presentation, and I forward the link to a blog post on the malaria data solutions, which is from this presentation. So, so I think scripts are in that article.
Yeah, there might be some small changes, but basically it's the same scripts. I will publish anyway another post today with a link to the most updated materials.
Perfect. I have one trick that I used in an application where, I mean, normally the application itself sometimes knows a little bit about the data distribution. So if I, for example, choose a customer from a dropdown, when I populate a dropdown, I might as well pick up some metrics from, let's say, is this a big customer or a small customer? And then if it's a big customer, I inject a string into the SQL query so that I get a different plan for that one than for others, so that I from the application, but then the application needs to know a little bit about the data distribution, otherwise it won't work. But that's one trick, just because of the query hash. If I put a comment into a SQL query, then it's another SQL query.
Yeah.
When it comes to the hashing.
That's a good suggestion. I think the question is, where should you put this logic? Should the application know about data distribution, or maybe it should happen inside the database itself in some way?
Yeah, Yeah, and I've done other ugly tricks with. Actually, I've implemented a solution where I run an agent job every 5 minutes to see if the statistics for the it's the when I came across an ascending key problem, basically. So I looked at the if the biggest value I had for a date was not in the statistics, then I forced an update of the statistics so that it wasn't the report that was really urgent to run really fast that came across and forced the statistics update for us. So it didn't have to wait for it. So, but
right.
This
is another very common problem, the ascending key problem.
But I hadn't seen. I mean, I really like the idea of picking up the histogram and just remove the small ones and keep the big ones, and then join to that one in the query. So
yeah,
or look at that. So that was a really elegant solution, I think. Even though I mean it's a lot of work and you need to maintain it as you said, but it's I like the idea of it.
I have a whole session, an hour session, just about that, the ascending key problem. There's so many things to know about that, how to deal with it.
Yeah, and I have a couple of presentations on statistics. It's both ascending key and other types of statistic problems, and you know the way SQL Server, the many different ways that SQL Server does the cardinality estimation. It's I mean it's a science in itself to try to understand how the optimizer works sometimes. So
yeah, absolutely.
I don't see any questions. I just see that people are they like the presentation, and so did I. So
great, thank you very much.
I'm gonna go back to listen to Haney and learn a lot about Terraform now.
Cool, enjoy.
Thank you so much for coming back to SQL Friday.
Thank you.